Well, how's everybody doing out there? Well, welcome to day 9 of Corona Online School. So I just want to say I thought you guys did an awesome job on the exam. There were lots and lots of good scores, awesome models and everything. So I'm very proud of how hard you guys worked. So now we're moving on to chapter 3, which is going to talk about some kind of representing big numbers. So up to this point, we talked about like additions using models with small numbers. So now we're going to get into bigger and bigger numbers. So it's unfortunate we're not in class because we'd be using base 10 blocks and things like that. So we're going to study some different bases in this section. So base 10, base 5, and then I'm going to have you guys do a little research project on some older number systems that involve some weird bases and things like that. So that's coming down the pike too. So to start off with, for example 1, what I want you to do is kind of take a piece of paper and label base 10 at the top and write the numbers 1 to 100 in the column, and make sure you line up the columns so that when you write them, you're looking at like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So notice how I got kind of the ones position, the tens positions lined up, and then kind of go through and do that. And then when you're done, come back and we'll kind of go through these questions together. All right. So in this case, what we're looking at is how many digits or symbols does our base 10 system have? So hopefully somebody out there is yelling 10. So our system has 10 digits or numbers. So you'll see when you're doing the other numeration systems, like sometimes they use symbols, all kinds of weird stuff. So for us, let's list our digits. So in this case, we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So those are the only 10 digits that we have available to use. And then it says, does the number 10 have a unique digit? And so in this case, so notice it kind of starts over at 10. So we counted up to 9, and then we made this a 0, and then we put a 1 in the next position. And if we would have kept doing, this further and further out, 1, 1, 1, 2, whoops, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 9, 2 zeros. So same thing. Once we get to that 9, this becomes a 0, and then we add 1 to the next position. So in this case, our 10 is a nice unique number. And I kind of answered D, what happens after the 9 appears in the ones column. So it becomes a 0. And then we add 1 to the tens column. And then when we got the whole way up to 100, hopefully you noticed that we made the ones column a 0, the tens column a 0, and then we added 1 to the 100 in that case. All right. So just to kind of give you an idea of our different positions here. So we've got our hundred thousands positions, 10,000s, thousands, hundreds, tens, and ones in this case. So in our decimal form, 1 is just going to be plain old 1. In our tens form, this is just going to be 10. Our hundreds form, this would be 100. Thousands would be 1,000. 10,000s would look like 10,000. And then 100,000 would look like that. And so in powers of 10 form, since this is our base 10 number system, then everything's going to be a power of 10 raised to some exponent. So if we remember from last time, our exponent rules, anything raised to the 0 power is 1. So if we want to get that 1, we have to take 10 and raise it to 0. So this is 10. So it would just be basically 10 to the 1. Hundreds, we'd get 10 to the second. Thousands, we'd get 10 to the third. 10,000s, we'd get 10 to the fourth. And then finally, 100,000, we'd get 10 to the fifth in this case. All right. Everybody okay so far on these? All right, perfect. So now what we want to do is look at what's called expanded notation. And so what this is really just taking a number and breaking it down into ones, tens, hundreds, thousands, however it may be. And so the plain expanded notation just writes them exactly in that form. So 3,000 would be just written as 3,570 plus 4. But then if we go a little bit further, we can write this in what's called exponential notation. And then what we're going to do is replace like the 3,000 by the 10 to the third. So that way we can represent it by its powers of 10 form. So in this case, this is what the same number would look like in expanded exponential notation form. So usually when I do it, I kind of write it in this form first, and then from there turn it into that form. But you can do it either way. It doesn't matter. It's up to you. So for 1, I'm going to say it's right in an expanded notation. So again, I'm going to write both of them just so we can see what it looks like. So in this case, 300. Oh, this is for you guys to practice. So you guys do this on your own, and let me know if you know what's going on or if you're confused or anything like that. Just check with me, and I'll let you guys do those on your own. All right. So representing whole numbers using base 10 blocks. So if we actually had these blocks, we'd actually see that the one that we're calling a little dot would actually be just a little square. This strip would actually be like 10 little squares put together. A mat would be a 10 by 10 square all put together. And then the cube, which is the thousands, would be a 10 by 10 by 10 cube all put together. And so what we want to do is actually write different numbers using these base 10 block notation. So in this case, if I wanted to write 546 using base 10 blocks, then in this case I need 5 100s. So that means I'm going to get 5 squares. 4 tens, so I'm going to get 4 strips. And then finally, I want 6 units, so I'm going to get 1, 2, 3, 4, 5, 6 dots in that case. So that's exactly what 546 looks like in base 10 blocks. So again, it's kind of like the expanded notation, but instead of using numbers, we're going to be using these symbols and things like that. All right. So you guys do the same thing for practice 2, practice 3, practice 4. And then let me show you a little bit of example 3 here. So this is going to help. And again, if you want to pause the video at this point, go ahead and do those practice problems, then come back. This is going to help us for when we're starting to talk about adding whole numbers and subtracting whole numbers, just to see like one of the kind of regrouping techniques and things. All right, so suppose the number is represented by 13 units, 12 strips, and 2 mats. So what exchanges must be made in order to represent the same number with the smallest number of manipulative pieces? Draw a diagram to show the exchanges. So first let me just kind of draw out what it explains. So I've got 2 mats, so that means I've got 2 squares. I've got 12 strips, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then 13 units, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the thing to remember is, since we're in base 10, none of these positions should ever have more than 10 things in it, whether it's 10 dots, 10 strips, 10 squares, because if it does, that means we could regroup those guys and turn them into the next line over. You know, like if we wouldn't write a number like this, like if I had 42, for example, I wouldn't write this as 3112, but that's kind of what that's doing, because it's taken this 10 and instead of writing it over here, it's kind of putting it in the unit spot, making it look all weird and stuff like that. So we want to think kind of the same way when we're regrouping these guys. So if I go through and look, in this case I can take these 10 strips or 10 units and turn them into a single strip in this case. So I can cash these guys in for a single strip, and now they're gone. And so same thing above, I can take these red here. I can take these 10 strips and turn them into a nice square over here. So I can cash these guys in, turn it into a square, and now those guys are gone. And so now, just take a peek, make sure everything that's in each column is smaller than 10. And as long as it is, then it means we're good to go. So in this case, I've got 3 mats, which is going to give me a 300. I've got 3 strips, so that's going to give me a 30. And I've got 3 units, which is going to give me the ones position. So in this case, that 13 units, 12 strips, and 2 mats could have been written more easily as the number 333, or again, 3 squares, 3 strips, 3 dots in this case, or 3 units. All right. Is that okay with everybody? All right, so again, pay attention to that. That's going to come in handy in this very next section. So if you didn't finish the practice problems, go ahead and stop this at this point and come back to the 3.2 video when you're finished 3.1. And I'll see you in a bit.